There's this very interesting question that I recently saw. So if we let f of x equal to e to the 3x cubed plus x plus 2, okay? And it has inverse f inverse of x. I'll call that g of x. So f inverse of x is equal to g of x. Okay, so first let's show that indeed its inverse exists, which means we need to show that f of x is injective, or it passes the horizontal line test. We know that e is injective, right? It's 1-to-1, it's always increasing. The thing is, what about 3x cubed plus x plus 2? It's a cubic function, so sometimes cubic functions are injective, sometimes they are not. So at first glance, I can't really tell if I eyeball this. So what I can do is I could take its derivative. Right? We'll need to use calculus for this question anyways. So f prime of x is equal to, we're taking the derivative of e to the something, so it's just that same thing. So 3 e to the 3x cubed plus x plus 2. But then by chain rule, we have to multiply by the derivative of the exponent. So 3x cubed plus x plus 2, the derivative of that is going to be 9x squared plus 1. Okay. Let's see. This e to the 3x cubed plus x plus 2 is always greater than 0. Okay. Since the base is positive. Okay, it doesn't matter whether the exponent is negative or positive or 0. The e to the whatever is always positive. Okay, and then 9x squared plus 1, this is always positive as well. Okay, because 9x squared is non-negative, but you're adding 1 to it, so it's greater than 0. So altogether, if you have a positive value times a positive value, this whole thing is always going to be positive. So we see here that f of x always increasing, which means that it passes the horizontal line test. Because you're not going to get two different values with the same input. Okay, that as you give me large numbers of x, as x gets larger and larger, the output gets larger and larger. And similarly, as x gets smaller and smaller, the output gets smaller and smaller. So f is always increasing when we move from left to right. So f is 1-to-1, or I should say f is always increasing. Okay, so f is injective, or people will say 1-to-1, which implies that f will pass the horizontal line test. Because if it didn't pass the horizontal line test, if you inverse it, the horizontal line is going to turn into a vertical line, so its quote-unquote inverse is not going to pass the vertical line test. The graph of its inverse function will not pass the horizontal line test. Vertical line test, which means this inverse cannot be a function in terms of x, right, where x is the input. on the horizontal axis, the x-axis. Okay, so we show that this e to the 3x cubed plus x plus 2 has inverse. If inverse of x, I'll call it g of x. So now, for question number 2, we want to evaluate what f inverse of e squared is, or what g of e squared is. Okay, so we want to evaluate g of e squared, and I'll call this y. So the way I do it is we let y equal g e squared, or sometimes I could write a bar or like a tilde to show that this is just a fixed value, a constant. Okay, but I'll just call it y. Okay, I'm not saying this is the graph y equals to e squared, g of e squared, like some horizontal line, but I'm just saying that y equal to g of e squared. Solve the y such that f of y is equal to e squared. Because if you apply f on both sides, like if g of e squared is equal to y, then the inverse of g, which is f of y, should give you e squared. Okay. The input for g is the output for f, and the output for g is the input for f. So here, y is the output for g, so we let that be the input for f, and e squared is the input for g, and thus e squared is the output for f. So f of y is equal to e squared, which equals to e to the 3y cubed plus y plus 2. Okay, and we know that f is injective or one-to-one, so which means that this exponent has to equal to 2, or the value of this exponent has to equal to 2, which means that if I just eyeball this, I know that y is equal to 0, because f is injective, so there are no other values of y apart from 0 that can make this equal to 2. Because e squared, e is also increasing, it's injective. So the only value you can put into the exponent so that it equals to e squared is 2, right? If you have a non-1 number, or non-zero number, say b to the a is equal to b to the c, then a is equal to c, provided that b is not equal to 0 or 1. Because if b is equal to 0 or 1, you're going to get a horizontal line at either 0, y equals 0, or y equals to 1. Okay, anywho, so we know y is equal to 0, but we can try to show that a bit deeper, even though we already know that there are no other values of y that could make this exponent equal to 2. But let's just see. So we have 2 is equal to 3y cubed plus y plus 2, which implies that 0 is equal to 3y cubed plus y if we subtract 2 on both sides, which implies that if you factor out the y, you get y times 3y squared plus 1, and we see here that this is always positive. Okay, this can never equal to 0. Okay, in the real numbers. So yeah, 3y squared is non-negative. You add 1 to it, non-negative plus 1 is going to be positive, greater than 0. So therefore only y can equal 0 in order for the right-hand side to equal to the left-hand side, which equals 0. So y has to equal 0. 0 times anything like positive or any other number, it will give you 0. So we get y equals 0. Okay, so then we know that g of e squared is equal to 0. All right. So g of e squared is equal to 0. Now, for question number 3, we want to evaluate what g prime of e squared is. So what is the slope of the tangent line at the point e squared comma 0 to the function g? Okay. So we want to first know what g prime of x is. Okay, what is g prime of x? So in order for us to do that, let's do some derivation. So if we let y is equal to g of x, this implies that x is equal to f of y. Okay, since f and g are inverses. Okay, so now what we can do is apply the derivative operator on both sides. We have d dx of x is equal to d dx of f of y, which implies that, okay, so what is d dx of x? D dx of x is equal to 1, and then d dx of f of y is f prime of y. But because we know that here y is a function of x, like y is g of x, right? We know y is g of x, so y is g of x technically. Like right here, like y is actually g of x. So we need to multiply by dy over dx. Okay. So which implies that dy over dx is equal to g prime of x. Right here, dy over dx is g prime of x, which equals to 1 over f prime of y, okay, which is actually 1 over f prime of y is actually dx over dy. Okay, right here, like dx over dy is f prime of y, if I'm differentiating with respect to y, okay. Well, that actually just equals to 1 over f prime of, well, what's y? Y is a function of x. So y is g of x. Okay, so that is just that derivation over here. I guess over here we didn't substitute y as g of x, which is because in this whole process we're letting x be the independent variable, but then over here we're letting y be that. We're differentiating with respect to y, kind of, and y is that independent variable of interest. But ultimately, you can write y in terms of x, and you can write x in terms of y. It generally, it doesn't matter which way you do it. So we can also like replace g with f. So we have f of x is actually equal to 1 divided by g prime of f of x. Okay, so they're inverse of each other. So this will also hold. Okay, so then we want to know what g prime of e squared is. So g prime of e squared, that is going to equal to 1 over f prime of g of e squared, which equals to 1 over f prime of, well, I guess when x is e squared, what is the value of y? Well, y is 0, which we found earlier, or g of e squared is 0, right? The value for y when x is e squared is 0, so f prime of 0, which equals to 1 over, well, f prime, we kind of solved that in the first question. So we simply just substitute this x for 0. So we have f prime of 0 is just e to the, so we have 0 plus 0 plus 2, so we have e squared. And then over here, if I let x be 0, I have 0 plus 1, which is 1, so this is just 1. So in the end, I just have e squared. So I have e squared. So that is the slope of the tangent line touching the graph G, okay, the graph of G, okay, at the point e squared comma 0. So with all of this in mind, we can complete what the main purpose of this question is to actually find the equation of the tangent line to the point e squared comma 0. So we have y minus y1 is equal to m times x minus x1. This is the slope point form. So we have y minus, well, our point is x comma y is equal to e squared comma 0. Okay, so I guess you can call it x1, y1. y1 is 0. M right here is actually g prime of x1, which we found was g prime of e squared, which was 1 over e squared, okay, times x minus x1 is x1 is e squared. Okay, so that's what we have. If we clean this up a bit, we get y is equal to, you can distribute the 1 over e squared inside the brackets. We have 1 over e squared times x minus e squared over e squared is 1. Okay, so I guess in slope point form, this line would have a slope of 1 over e squared and a y-intercept of -1. This is in slope-intercept form. Okay, so the y-intercept will be at 0, -1. Okay, so this was a very interesting question, and there's several theories, applications, knowledge that are to be known in order to do all these steps 1, 2, 3, and 4. Okay, so hope that this was enlightening.